Okay, enough. 11-4. Part 1. Adding, subtracting with the same denominators. These are rational expressions, just like this. 1/8 plus 3/8. They have the same denominator. This is easy. It's something over 8. Well, 1 plus 3, these are kind of just like terms. You add them together and get 4/8. Well, now, if you look for a common factor of 4 and 8, you find that the common factor is 4. And if you think about this, you go, well, 4 goes into 4 one time, and 4 goes into 8 two times. What you're really doing is factoring and simplifying in your head, and you know that comes out to be 1/2. Same thing goes for rational expressions that involve polynomials. Well, let's do one that starts off pretty easy. 2x plus 1 over x plus 1 plus x plus 2 over, well, if they have the same denominator, obviously the denominator is going to be the same, x plus 1. Sorry about the crookedness. Okay, let's go. X plus 1 and x plus 1 are the denominator. Don't think, just rewrite it. X plus 1. It has the same denominator, so you know it's going to be over x plus 1. Now, think about this, about factoring. Can you factor anything out of x plus 1 or x plus 1? No. So wrap these in parentheses, and I'll explain why in a moment. Now, 2x plus 1 plus x plus 2. Well, just like I did up here, I'm just going to combine like terms. Well, 2x and x give me 3x. 1 plus 2 gives me 3, positive 3. Now, just like I did here, I tried to think of a common factor. Well, now try to think of a common factor of the numerator. Hopefully you notice that you can factor out a 3, leaving you with x plus 3 over, same old, I said x plus 3, x plus 1. And hopefully you caught my mistake and why this is important to note. What happened when I factored out this 3? I got a common factor. Now I can simplify that and end up with my answer of 3. Remember, you can't cancel pieces of polynomials. Like, don't get tempted to cancel this x with this 2x or this x and this x. You can't do it unless it has been factored out. You can only cancel factors, not parts of polynomials. Okay, let's do example 2. It's going to be a little bit trickier, but not much. So if I wrote 9 over x plus 3 minus 3x over, you guessed it, x plus 3. Don't think about it too much. If they have the same denominator, just write that denominator right away. And again, notice that you can't factor anything out of that, so I'm just going to wrap it in parentheses so I'm not tempted to cancel anything. Well, now let's combine like terms in the numerator. Well, 9 minus 3x are not like terms, so you just write what you see. 9 minus 3x. Hopefully, you recognize that 9 and 3 have a GCF, a common factor of what? 3, I hope. Let's see what happens if I factor out a 3. 3 times positive 3 will get me 9. Okay, 3 times 3 is 9. 3 times what gets me negative? 3x. That's going to be negative x. Double check. Does 3 times 3 get you 9? Does 3 times negative x get you negative 3x? Now, how did that help me? It didn't. These are not the same factors. I can't cancel that. Now let's just think about it for a second before we've talked about factoring out a negative instead. If I factored out a negative, that would make that negative, that would make that negative, and that positive. Are these factors the same there? No, they're not. So either way, factoring out a positive, going back to what we had, or factoring out a negative, nothing is able to cancel, so I'm done. That's the answer. Okay, part 2. This is the harder one. Unlike denominators. You know when you add or subtract fractions, you need the same denominator. So for part 2, I'm going to do two examples that have different denominators. Okay, first one. If I wrote 6 over 5x to the 8th power plus 4 over 3x to the 6th. If I was to think about just those two denominators, 5 and 3, ignoring the variables, the common denominator for 5 and 3 would be what? You just said 15. Thank you. LCD equals 15. Lowest common denominator of these two fractions is 15. However, they both have variables in them. Well, they need x, but think about it this way. 5 and 3 are both factors of 15. Whereas, which factors do we need for x to the 8th and x to the 6th? We need it to be able to be bigger than either one of these or one of them themselves. So what I'm saying is, you need x to the something power. Well, do you need more x's or less x's to be a common denominator? And just look at the number. 5 and 3 go into a bigger number. So what you do is you look at the bigger power and choose that one, which is x to the 8th. And I'll show you why in a moment. Now, since neither one of these has the denominator that we want, we got to do something about it. And let's go back in time. If I said 1/3 plus 1/5, that common denominator 15 is true for this simple fraction. Well, what do you actually do to change it to get it to be the denominator? And hopefully you know that you're really multiplying this by 5 over 5 and this by 3 over 3. Now, why am I allowed to do that? Well, what is 5 over 5 if I think of this as a number of itself? This in itself is just a 1. So is this. And when I multiply something by 1, it doesn't change its value. Well, that's true for this too. What's missing from this factor that this guy has? In other words, what do I need to multiply this bottom, this denominator, by to get it to turn into 15x to the 8th? So if my goal is to get it to be fixed 15x to the 8th, and right now I have 5x to the 8th, obviously I just need to multiply this by what? 3. But I can't just multiply the bottom by 3, I have to do it to the top. So now, multiply by 3 times 5 is 15, x to the 8th. 3 times 6 is 18. Well, what about this guy? What's he missing? Which factor of 15x to the 8th is he missing? Well, first of all, he's missing 5. But he's also missing a couple of these exponents. He's missing x to the 2nd power because he needs to get up to x to the 8th power. So he needs the additional factor of x squared. So now I multiply that times 4 times 5x squared, I get 20x squared, over what we want. 3 times 5 is 15, x to the, add the powers, 8th. Now this problem becomes like the previous examples. We have a common denominator? Good. Put it over the common denominator, 15x to the 8th. Easy now. And now just combine like terms, which they aren't. So just write what you see. 18 plus 20x squared. Now, always try to factor something. 18 and 20 have a common factor of 2. So if I factor out a 2, I'm going to be left with 9 plus 10x squared over 15x to the 8th. Now, did factoring help me with anything? Can't cancel the 2 and the 15, and the x to the 8th can't cancel or simplify with this because this is part of a binomial. So in that case, you're done. Okay, last example. Running out of time here, so let's do example 2, harder problem. So 1 over 2x minus 2y. Press pause if I'm going too fast. Minus y over x squared minus y squared. Whew. All right. So step 1, you're going to have to do something here. You're going to have to factor this. Back here, these are just monomials, so it was pretty easy to see what the common denominator is. Here, we're going to need to factor this. So I'm going to write this. Step 1 is to factor. So let's rewrite this, and let's factor anything out of here that we can. Well, obviously the 2 is the GCF, leaving me with x minus y. Okay, minus. Now, this other binomial, I hope you remember that this is a difference of squares. So that looks like this when I factor it. X minus y, x plus y. Okay, now step 2. Let's get our LCD. Well, look, these are factors. Things that are multiplying are factors. this has a 2 and an x minus y. This has an x minus y and an x plus y. Well, I'm going to underline this and this because these guys are factors that they have in common. They already have an x minus y. Think of this as like a jealous brother or sister. Me and my brother always wanted the same presents, and we got jealous of each other if we didn't get it for our birthdays. Well, he got a 2 and an x minus y. I got an x minus y and an x plus y. What does he get that I don't have? See how he has a 2 and I don't have it? Well, we all both want a 2. We both want an x minus y. Now, is he jealous of me? Yeah, I have an x plus y and he doesn't. So if we were to get all the same presents, we would get a 2, an x minus y, and an x plus y. So now, what is he missing that he wants, and what am I missing that I want? Well, if this is my common denominator, if I want us both to have 2, x minus y and x plus y, I'm just rewriting the problem here, x minus y, x plus y, and hopefully the 2. What's he missing? He's missing x plus y. Now this looks weird, but it's just a giant 1 again. Remember, anything divided by itself is just a 1, and when I multiply by 1, I don't change a value. What am I missing? Well, mine's easy. I'm just missing the 2. So I multiply by 2 over 2. Okay, so now I'm going to keep this denominator to get what I want. Now, 1 times x plus y is just x plus y. I'm just distributing the 1. Now be careful with this minus here for a second, so let's take our time here. 2 times y is just 2y. Now remember, that's a negative sign, so if this was more than one expression here, you'd have to distribute it. But since it's just a 2y, we're going to take it to the next line here and see how we deal with this. So now, do we have the denominator that we want? We sure do. So let's copy it to x minus y, x plus y. And in the numerator, we're just going to combine like terms. And notice these are like terms. But be careful, that's a minus. So x, okay. Positive y minus 2y is negative y. Okay, did that help us in any way? Well, check it out. Isn't x minus y and x minus y a common factor? It is. Well, can I simplify them? I can. And when I do, what am I left with? Well, when I simplify something by itself, really, you remember you're just dividing out a 1. So what you're left with up top is 1. And what are you left with at the bottom is 2 times x plus y. That's all, folks. Enjoy.